Okay, so now we're going to look at this side of the note sheet and we're going to focus on some application problems and go through a few things. And these should all look very, very familiar from your geometry class, but it doesn't hurt to review it since it's been a little bit since you have completed these kind of things. So these are all application problems. So we're going to draw a picture or a triangle to represent the situation, and then we'll go through. We're also going to use our calculator. So let's start out by going to our calculator and doing a second plus 712 reset. So second plus 712, and that resets the RAM and shuts things off that don't need to be on. When you press the mode button, you should see that it automatically resets to Radian. That's where you're going to calculate all the time, except when the problem specifically has a degree in it, and then you're going to change to degree mode by arrowing down to where the Radian is, going over to where it says degree, and hitting enter. And you can go ahead and set that up right now because all of the things we're doing today are triangle problems, which are measured in degree measurements. So that's what we'll be using. And then when we're through, we're going to immediately come back to this mode window, change back to radians. So really get in the habit of switching back to radians so you don't accidentally calculate something in the wrong mode. That would not be good. So the first problem says solve the triangle. That means, remember, finding all sides and all angles. So I'm given triangle ABC. I'm given the measure of A, which is 34.2 degrees. I'm giving a length of B, which is 19.4, and I'm given an angle C, which is 90 degrees. So I'm going to draw my triangle ABC. I'm going to label angle A and C and side B, and then I'm going to look to see what it is that I have missing so that I'll know what I need to calculate. So when I go to the triangle, I'm going to lay it out, and it told me that C is 90 degrees, so that has to be my C. I have an acute angle, so I'm going to put it right here. I'm kind of a creature of habit, and I tend to kind of lay things out in the same way each time. So, you know, if yours is a little different, that's okay, but it should be the same idea. And remember that this is a degree right here. Okay? Please get in the habit of always putting degree measures on your angles, because as we move into section 4.1, we'll start talking about radian and degree measures, and anything that does not have a degree symbol will be considered a radian measure, and those are very different units of measure that we're going to learn more about. So then we have the length of B, and remember we said that the side B goes across from angle B, so this is side C, this is side A. All the sides are lowercase letters, all the angles are uppercase letters. So now that I have everything laid out, what is it I don't know? I don't know the length of this side, I don't know the length of this side, and I don't know this angle. So those are the things that I am going to find. So I am going to start with finding B, because that's super easy because it's just an angle. We know there are 180 degrees in a triangle. We're going to subtract C, which is 90 degrees. We're going to subtract A, which is 34.2 degrees, and that is going to leave me with 55.8. So I have solved this angle. So now I'm going to do the sides. So to find side A, I'm going to use this angle, and this angle has an opposite side for A and an adjacent side for B. So I want to figure out which trig ratio uses opposite and adjacent, and that happens to be tangent. So then I set up my tangent of 34.2 degrees, and it's A over 19.4. I expect to see this statement in your work, and I expect to see the statement where you have isolated A before you go to your calculator. So those two things should be part of your work. I am looking for that as your supporting documentation when you're working these problems. So we've already kind of talked about, I have some calculator reminders over here. We've already talked about that a little bit. So as those pop up, we'll kind of address anything we haven't. So now I go to my calculator. So I actually go into my calculator. I have already changed it to radian mode. I go to my home screen. I do 19.4, tangent of 34.2, and I get 13.1842269. And remember, we do everything to 3 decimal places. So I went ahead and wrote everything out since these are your notes, and then we're going to do a solution statement at the end, and we'll do all our things in our solution statement to 3 decimal places. Okay, so then it would be this, and I put units here just because it kind of bugged me that we didn't have units on the problem, but you don't have to do that. And actually on the College Board exam, you don't make up units when you're taking your calculus exam. So technically those wouldn't be there, but I figured for note purposes, that's a good thing. Remember that if you need this information in a future calculation, you want to store it. And I always put quote marks around my A just so I know what I have stored. So now we're going to find C. And so that's this distance right here. And so that means I'm using the given, which is the adjacent, and the hypotenuse. So I need the trig ratio that's adjacent hypotenuse. That happens to be cosine. So I have cosine of 34.2 degrees, and then I have 19.4 over C. So then I get C by itself, and so I would multiply both sides by C and then divide by cosine of 34.2 degrees. So that's what it looks like when I have taken care of that. And so then I can go to my calculator and I can do 19.4. Let's get a fraction there. So alpha equals, and I have 19.4 over cosine of 34.2, and that gives me 23.455996764. So keep in mind that we never round until the very end. So, make sure you're getting everything in here and you're not trying to round intermediately in the problem. Okay, so now that we know that's our answer, our solution would be angle B is this, angle A is approximately this to 3 decimal places, angle C is approximately this to 3 decimal places. I usually ask you on assessments especially to give a solution statement, because as we move into things like law of sines where we have the ambiguous case, sometimes a triangle can produce 2 entirely different solutions. And so you don't want to get this little A mixed up with another A in the other triangle. So I always say, we just kind of make some sort of solution statement for each problem. Problem 2, the base of angles of an isosceles triangle measure 18 degrees and the base measurement is 10 meters. So we do have units on this one, and we're going to find the altitude of the triangle. So in this particular problem, we draw our triangle. So we have the 18 degrees down here. We drop the altitude for the right angle. This whole distance was 10. When we drop the altitude, now it's 5 meters and 5 meters. And so then we can look and see what it is we need to figure out. So remember, this does have a unit here, here, and here. All right, so I have an angle, so you can decide which way you want to go from. I'm going to go from here, which means I'm looking at the opposite, and I have the adjacent, so that means I'm using tangent again. We tend to use that one a lot. And so it's tan of 18 degrees equals A over 5. Rewrite it so A is by itself. So I get 5 tan 18 theta. And then I go to my calculator and I type in 5 tan 18 degrees and I get 1.624598481, which is right here. And so my statement basically is the height of the altitude is 1.625 meters. And so that's where I've rounded it off. I've made sure I've used my units because it's an application problem. Problem 3 is what we call a stackhouse problem, in this case a smokehouse problem. But this kind of problem shows up a lot because we have houses that have direct TV dishes on top or dish network dishes on top. We have towers that have cell phone towers that problems can be written up. In this case, we have a smokestack. So at a point 200 feet from the base of a building, the angle of elevation to the bottom of the smokestack is 35 degrees and the angle of elevation to the top of the smokestack is 53 degrees. Find the height of the smokestack. So we need to draw a bit of a picture here. And so here's my building. Here's the smokestack up here. At this point that's 200 feet away to the bottom of the building or the bottom of the smokestack, the top of the building, I guess, would be this 35 degrees. And then all the way to the top of the smokestack would be here. And so that's the 53 degrees. So hopefully you can see we have a smaller triangle here. We have a bigger triangle here. I'm trying to find this distance. That's how tall the smokestack is. I can use the small triangle to find how tall the building is, which gets me to the bottom of the smokestack. But look at the big triangle. I have a piece of it missing. So I kind of have to have a plan here. So my plan is going to be to find the height of this, which is A, and then I'm going to find the height of the whole thing, which would be x plus A, and then I'm going to subtract them to figure out what x is. And so that's my plan. So the first thing I'm going to do is find A. And so A is this piece right here. So I have adjacent and opposite, so I'm using tangent again. and the angle for that little triangle is down here. That's 35 degrees. So tangent of 35 degrees equals A over 200, and I get this. Now you can do that whole thing and store all in one step. So I go into my calculator and I do 200 and I do tan of 35 degrees. And then right here, press the store button. And now I'm going to press alpha A, and that's going to store that value. So it calculates it and store it. And remember, when I do it in my work, I put quote marks around my A so that I know this is a stored value that I can use at a later date. So now I'm going to find the length of x plus A so that I can solve for x. And so when I do that, I'm using tangent again because I have this whole side and adjacent. So I have tangent of 53 degrees equals x plus A over 200. So I get x plus A by itself, and I get 200 tangent of 53 degrees. Remember, A is just a number that we stored, so we have a value here. It's not an unknown. And so I just subtract it from both sides. So now I can go into my calculator and use that stored value, and I can say 200 tan of 53 degrees this time because that's the big angle, and then I can do minus alpha A, and that gives me my value there, which is what C is. So actually when I calculated this, I'm actually setting it up so that I can calculate X at the same time. So the height of the smokestack is 125.367, and we do have units on this one, which are feet. So that's how tall the smokestack is. And remember always to 3 decimal places unless you're told otherwise. All right, moving on to our last problem. So number 4 is the length of a shadow of a tree, and it's 125 feet when the angle of elevation of the sun is 33 degrees. Approximate the height of the tree, and we're doing that using the shadow. Now, I know it may sound crazy, but I have people that ask me about the shadow, and they ask, is that the hypotenuse? Well, think about that for a minute. A shadow is going to be on the ground. The sun is actually shining from behind, so it's casting the tree shadow on the ground. So here is my diagram. So I have my tree. The sun's back here, shining this way, so it casts the shadow down here. Yes, I know I'm not an artist, but you get the gist. There's my shadow. This is the 33 degrees that we're talking about, and the height of the tree would be over here. So that height of my tree I'm going to call X. The shadow is 125 feet as defined in my problem. So I need opposite and adjacent, so once again I'm using tangent. So tangent of 33 is the opposite over the adjacent. I get X by itself because that's what I'm trying to find. I go to my calculator, I type in 125 tan of 33 degrees, and I get this decimal, which means that the height of the tree is approximately 8.176 feet. So I hope this has given you a good sampling of how to work through some of those problems from geometry, right triangle trig problems. Sometimes we've got the ladder leaning against the building, and those kind of problems can come in this section as well. So work through these problems. So remember, you have 2 DP practices. You have a daily practice in Canvas for 4.3 and a separate daily practice in Canvas for 4.8. So I didn't want to put all of that together in one piece, so that way you can focus on basic skills from 4.3 and then you can focus on application skills for 4.8. So next time we meet, we're going to be going back in time to section 4.1, and we're going to start talking about the basics of trig, the difference between radian and degree measures, and make sure we're all in a good place. Thanks. Bye, guys.